It's, you know.
Easy one should be go to the UK.
Yeah. It's
Okay.
very complicated situation. Very complicated.
Okay, sounds good. Let's go to second part. You finish speaking in German.
Good speaking topic, yes. Yes.
What? Come on. I even don't
Although
know.
I think that would be too difficult and too controversial for a speaking exam.
Yeah.
Okay. Obviously in China it's allowed.
Yes.
Yeah.
Yes. Encouraged even. Okay. What one are we on now? Page 27.
Yeah.
Second question. Yes. Easier or harder than the first question?
Hard.
Doesn't look too bad. Okay. So we have our line. 3 plus 4 lambda. 1 minus lambda. 4 plus lambda?
It's 0.
Huh?
Oh, yeah. 1 minus lambda.
Don't confuse me, Jerry. 4 plus 4 lambda. It confused me. Hang on, let's start again. Right. 3 plus 4 lambda.
Correct?
1 minus lambda.
Correct?
4 plus lambda.
Correct?
If lambda equals minus 1, this equals minus 1, 0. No, what am I saying? For goodness sake. 1 minus minus 1 is 2, and 3, which equals A. So that answers the first part. Right? Yeah? So the second part. Here's our line. A is on the line. B is somewhere here. And that's, I don't quite have it in my picture here. That's perpendicular. So if it's perpendicular, it means 4 minus 1, 1 dot AB equals 0. Now the reason I'm using 4 minus 1, 1 is because it's these numbers, which represents the direction of the line, and that dotted with that should be 0. That's what you were talking about earlier, Monica, I think. No? Yes? What's... Yeah. So 4 minus 1, 1 dot B minus A minus 2 plus 1, P minus 2 minus 2. That should equal 0. So minus 8 plus 4 minus P plus 2 minus 2 equals 0. So that means P equals minus 4. Is that okay? Yeah. 4 minus 1, 1 is this vector here. It's the coefficients of the line.
Where's 4 minus 1 from?
You just asked me that. It's this vector, the vector on the line. Yeah.
So how? We have it.
Look, Jerry, if you have A plus TB, or A plus lambda B, we'll say, that makes a line. The B is this vector
Oh yeah.
on the line. That's the B.
Ah.
Yeah.
So we use 4I minus J plus K something like that.
Yeah.
Oh.
Now we want to show that this line, 3 plus 4 lambda, 1 minus lambda, 4 plus lambda, does not meet this line. 2 minus 3 mu, 2, and 1 minus 2 mu.
So teacher, I have a question. So it's always equal to 0, right?
That product, if they're perpendicular?
Yeah.
Yeah. So if I compare this one with this one, I get lambda must equal minus 1. And if I put that in here, I get 3 must equal 1 minus 2 mu, which means mu must equal minus 1 as well. So, if I use minus 1 and minus 1, I get minus 1. Good. I get 2, and that's a 2. And I get 3, but the problem is here. 2 plus 3 is 5.
Where did you get the 2
Hmm? Mu is 2? What?
Oh.
So, if these match, then it means this should match. And because it doesn't, it means they don't meet. What's happened is it looks like they meet. Maybe this is if you're looking like this, X and Y. But if I look here, X and Z, you know, if I'm looking down and then I turn it and look the front, maybe it looks like this. You know, they look like they meet from the top. This is from the sky. But then when I look at the front, they don't meet. Because what's happening is perhaps this is happening. That they look like they meet, but actually it's just that one passes under the other. I think that's the best way to picture why they don't meet. They look like they nearly meet, but they don't. So in 2 dimensions, 2 lines, unless they're parallel, they must meet. But not so in 3 dimensions, because they could look like they meet, but then are actually parallel in the extra dimension. Passes under rather than meets. Yeah? What's this? 10 marks? That's alright. It's alright.
Physics.
Physics next?
You know what?
Can I close this first?
Yes,
Yeah.
yes,
Go on.
I print out the partial paper like Saturday,
Yeah.
and then which is physics partial, and
Yeah.
then it's very hard.